Konnichiwa. Hello, everyone. It's so nice to see you. So many of you. Hello,
Hi, Paolo.
Paolo. It would be very nice if you
Morning,
can all please turn on your videos so we can see you. It is
Yes.
really... Hello, Tomoko.
Hi
Hello,
to
Professor
everybody.
Tanaso.
Very nice. Hi,
Oh,
Harold.
dobar dan, Dragomire. Oh, Professor Martens. Hello. Very nice to see you. Oh, Kanaji-san, beautiful. Hello. Hello.
Hello, hi.
Hello, Charles Henry.
Hi,
So,
Sumiyoshi.
Hi, Giuseppe.
Hello.
hello,
Nice to see
Yoko-san.
you.
Oh, hi.
Oh, beautiful to
Kaji-san.
see such a large number of people with us today. So officially, let's start. Hello,
Aquaphotomics.
everyone.
Great.
You're very, very welcome.
Hi.
I'm very happy that after a little bit long break in our webinars, that we are now continuing with Aquaphotomics webinars. And for a start, we have really a very exciting lecture and a wonderful scientist and a speaker with us today, Professor Guiseppe Vitiello. So as usual, we will have first lecture, and then afterwards we will have a discussion. But in the meantime, of course, you can type your questions when you, for example, when something occurs to you during the lecture, you can type your question in the chat box or in questions and answers, and then we will go through that lecture, go to that questions afterwards. For the people from Japan, I would like to emphasize that we are now enabling Japanese live translations. If you need it, I think that would be very good. And of course, as always, the webinar will be recorded and available in a few days on our YouTube channel. So from me, I would really like to express my gratitude for all of you who came. And Professor Tsenko, would you like to add some few words?
Yes. Very welcome to everybody. Happy to see you all. And thank you very much to Giuseppe for accepting our invitation. We had a very, very interesting conference together this summer on consciousness, and it is a kind of continuation in this direction. This is something that we're going to work on this in the future, I'm sure. So I'm definitely you will enjoy our talk tonight, and I'm looking so much forward to it. Thank you.
Thank you. So then, just before we begin, I would just like to add a few words about Professor Vitiello. I mean, you read, of course, the announcement and you read the abstract, but I would like some personal, association. I first met Professor Vitiello in 2012 at Water Conference in Vermont, and that was the first time that I've heard the talk about the consciousness and even water related. And one of my first, memories that whenever I hear name Guiseppe Vitiello, my next association is log plot. So I remember when I had a poster at that conference, Professor Vitiello came and he commented on my results, and he said, you know what, why don't you do the log plots of this, and then that would be the evidence of coherence. So since then, I'm really interested in that. I read a lot of papers, but there are a lot of things that I still don't understand, and I hope that your lecture today will, help me with this. So I'm also very, very grateful, and it is an honor for me to be here. So now, thank you very much, and you can share your presentation. I will let you know when 25 minutes is approaching. So if you need anything, just let us know. You can begin. Thank you.
So thank you very much to everybody. And I don't know, you see me?
Yes.
Can you hear me?
Yes, we hear you very well.
Everything is fine, yeah. So thank you for all this nice presentation by you and by Professor Rumiana Zengola. But I do not deserve so much. I'm just a worker. I mean, and just playing around with the little toys. That's it, and no more than that. So in any case, thank you a lot. Maybe I start by sharing the screen so I can go directly to the problem. By the way, I suppose, I'm sorry, Elena, I will not have a log plots in this talk, but of course they are there. I mean, you have a, okay, thank you. So let me share the screen. Where is, I should find, yeah, maybe it's this one. Okay, can you read it?
Mm.
Can you see?
Yes, we can.
Yeah. Okay. So the title, I mean, is just catchwords: water, coherence, and consciousness. And by the way, consciousness is in my model. I should not even say mine because it's the result of many collaborations. But in any case, in the way I see brain modeling, consciousness is a function which has to do not so much as people say in this locution, these words, neuronal correlates, which actually I do not know what that means, but in any case is something which has to do with dissipation, namely with the fact that the brain is an open system. But we will go on that point maybe here I give you a few references, but you can find easily in some papers. They are always the same. Now, I realized that is a long time ago when all this story started, even before 1995, which was the paper on dissipation indeed, and the memory capacity in the quantum brain model. Actually, all of it started around 1983. Let me go, let me see how to change this. Yes, when we had were so lucky to meet Herbert Frohlich, who wrote even long time before than we met him, famous papers. This is one of those about long-range coherence and energy storage in biological systems. And this title is really a research program, I would say, because also in this title, there is long range. We will see how it, long range correlations, how it appears dynamically in living matter in general, not only in the brain. And then again toward the coherence, which is a crucial word in all this story, and the energy storage, which is something which, let me say, has to do with the free energy. And maybe we will make some comment on that. And has to do with the fact that when a system has a structure, there has been some energy invested, how to say, used to construct that structure. And that energy can be used by the system by disgregating, by destructuring, and translating that structured energy into a kinematic dynamical regime. And this is a very interesting process. But in any case, he already was talking of energy storage in biological systems, so in very general terms, not just for the brain. Oh, sorry. Then I give you a few quotation from What is Life? Schrödinger set of lectures. And he, of course, he could say something which might sound also not so nice with reference to as he call, you will see, classical physicists. In any case, The point is that very often we just have a naturalism, namely a collection of data. And we think that that is science. Science is not just collection of data. Science is, that is the naturalistic level. Science is when you understand the dynamics, namely the correlations among those data. So when you find the dynamical unifying laws. And Schrödinger was saying that the order that we do observe in living matter is cannot be generated just by statistical mechanism, but is generated by dynamical interactions. These are quotations from Schrödinger of What is Life. In the edition I have is page 80. And he, in a very strong way, he say it needs no poetical imagination. You see how to say strong his statement. It needs no poetical imagination, but only clear and sober scientific reflection to recognize that we are here, obviously faced with events whose regular and lawful unfolding is guided by a mechanism with quotation marks, he puts quotation marks, entirely different from the probability mechanism of physics. So he's searching for laws which are not just of statistical nature. And in fact, in some other page, I give you always the page of my edition, page 78, he says that the regularities only in the average, which are of statistical mechanism, the ones you can get in that way with the statistical mechanism, are not enough to explain what? The enigmatic biological stability. So stability means here functional stability. And because of course, living matter is always going through physicists, as we physicists say, through phase transitions. So the attempt to explain biological functional stability in terms of regularities of statistical origin would be, he says, the classical physicist expectation that, far from being trivial, is wrong. He does not use half words, how to say. Also think that we are in years where indeed quantum mechanics was in some sense fighting to be accepted by the largest community of classical physicists indeed. Now he insisted, he says the naive physicist on page 20, does not bring to concrete advancement on answering such a basic question. So he just said there is no possibility to get answer from classical physics. You need quantum physics. You need quantum physics. Let me go to last 2 lines of these slides. Because naturalism is not sufficient for the comprehension of the system at the level of a collective behavior. So what we have to explain are collective behavior of, let's say, components of the system, microscopic components. So this is the background. And when we met Herbert Frolick, when I say we, I mean Emilio Del Giudice, Silvia Doglia, Marziale Milani, and myself. We met him and we became very well, I mean, there was just an empathy among us. Herbert Frolick was really a great person, a very sensible person, and of course a great scientist. So we started to thinking along these lines. And as a physicist, we had a tool, and that tool was the spontaneous breakdown of symmetry, but not in quantum mechanics, where you do not have a spontaneous breakdown of symmetry. For the simple reason, you do not have different I will tell you what I mean by different representations of the canonical commutation relations, which you do have instead in quantum field theory. So by using quantum field theory and the mechanism of the spontaneous symmetry breakdown, we could get a boson condensation in biological systems. Boson condensation means collective modes. I will go back, of course, on these things. When I say the different representation, in technical words, you would say unitarily non-equivalent, namely representations which cannot be related by any unitary, not operating with any unitary operator to move from one representation to another one. But consider that representations are Hilbert spaces, so they represent, sorry for the fight of words, they describe, let me say, different dynamical regime, physically different dynamical regime. And biological matter is living only when it goes through phase transitions. If you stop such a process, you will have not anymore a living matter, but a dead matter, inert matter. So one of the first difference that we can see between living matter and dead inert matter is that in living matter, the dynamics is a dynamics of a continuum undergoing through phase transitions. This is the main aspect that we can think of at this moment. That was the idea behind these papers. And this paper, this was a physics letters A of the 30 May 1983. And I was realizing that is really for a long time. And now it's 23. So we are talking of 40 years ago, practically. Then we had another paper, a longer one with more formulas that we, as a title, gave a quantum field theoretical approach to the collective, you see the word collective comes always in, behavior of a biological system. And this was we had many formula in this paper, so there were no journal of from biology research that biologists could read. So we had to publish on this nuclear physics. At that time there was FS field and statistics, and this was in 1985. And the quantum field theory apparatus was in this paper, and that is in this paper without considering the gauge field, namely the electromagnetic interaction, because it would be too long paper, which we did instead, I mean, introducing electromagnetic field and spontaneous breaking in biological matter in the subsequent paper in 1986, always on nuclear physics. This fact that we were publishing on physicist papers, journals, is to me, how to say, I find it very interesting because afterward, we realized that actually biology, which deals and has to deal necessarily with biochemists, after all, that is not touched by our papers, because we are talking of the physical laws underlying the biological activity, the chemical activity. So the fact that we had not the possibility, just because there were not, I mean, too many formulas to publish in a journal devoted to biology, this fact was not accidental, was correct. Was correct because we talk about physics and we propose to biology a view of biology resting on dynamical laws underlying the biological activity. So there is also no conflict with biological views, but there is the attempt on the basis of Schrödinger invitation, suggestion, to find dynamical laws underlying even the statistical approach that necessarily you have in a biochemist, where molecules, you have chemical reactions just on the basis of a randomness of their crossing through. But that randomness is tamed by the physical laws which are below. So, for example, this I used to say, which one is the probability that in a day like this, 17 October 93, which one is the probability that I could speak with someone of you just sitting there, amongst how many billions of people are we on the earth now? Maybe 7, I don't know, something like that. That probability would be 0. But sharing a long-range correlation among us, which consists in our common interest in these things I'm talking about, that has made non-zero probability for us to meet this morning. This is the way in which physics tames the randomness of biochemists and makes us so extremely efficient and long-lasting the functional activity of living matter. In those years, we were working in between Salerno and Milano, and Giuliano Preparata, he was not yet arrived to Milano from Bari, where he was staying before. And when he arrived to Milano, just for the characters of many of us, we had no other choice than interacting with him. And then a fruitful collaboration was born in that way. So we wrote in 1988 this paper, which is about water as a free electrical dipole laser. And this part, free electrical dipole laser, is because Giuliano was working on free electrical lasers. And then he saw that in what we were saying about collective modes and all that was much more, I mean, not much more, but was really similar to what you have in a coherent system like a laser beam. So the coherence we were talking in our papers extended in some sense to other fields in a quite easy way, I would say. And then a very dense collaboration was born between Emilio Del Giudice and Giuliano Preparata. They were both in Milano, and both of them, they were working mostly at night. Sometime I went to Milano, we had a discussion, then we appointed to see, I don't know, in a week, but in the morning when I was arriving to Salerno, Giuliano was calling me that he already did the computation during the night when I was sleeping, traveling by train to Salerno. So this was the idea. Giuliano was really... now, there was another element which came in the story, was the fact that we met with Carl Pribram and with Walter Freeman. And this created really, I mean, when I met Walter Freeman has left his fingerprint on neuroscience, on modern neuroscience. He left us in 2016. And then I dared to tell him when I met him, talking of these things, I told him, well, you will be my experimentalist. Of course, he was smiling because nobody dared to talk to him with such, how to say, familiar, friendly way. but I did need somebody looking in neuroscience laboratory what you do observe about the brain, because the theoretical modeling I was involved, otherwise it would be just dreams or something like that. So a lot of elements coming from real, I would say, the knowledge of facts occurring in the brain activity came through, and he was calling packets of waves what he was observing, namely these, I propose to call them blobs, because they looks as we were calling with Emilio coherent domains of neurons, of myriads of neurons oscillating in syntony. And the time scale of such oscillations, neuronal oscillation, is the time scale is milliseconds, and the duration of this formation of packets of waves is between 80 and 120 milliseconds, and the frequencies in the beta to gamma range, which means 12 to 80, even 100 Hertz. So packets of waves, this is not quantum mechanics wave packets, but is Freeman way of talking about neuronal coherent domains. And these domains, they form and they decay and they form again. And all of this happens always in the range of a few, I would say, Hertz. Which is very, very interesting, because there are also, let's say, geophysical phenomena around that frequencies. I'm thinking of Schumann frequencies, for example, which came in another collaboration with Luc Montagnier, but I will not say anything about that because it's too long otherwise. Now, these coherent domains, they might extend, they might be very large, extending even to a whole hemisphere of the brain, which is 19 centimeters in humans, and smaller, of course, in rabbits and cats or other small animals. So this was the situation, but this situation was described, I learned, very well by Lashley in the middle of the 40s, when by himself he called such a situation a dilemma. He writes, Lashley, nerve impulses are transmitted from cell to cell through definite intercellular connections. So connections are there. They are anatomical, let me call them anatomical connections, namely dendrites, axons, synapses, and all that. Yet, all behavior seems to be determined by mass of excitation. Here is the collective. You see, Lashley was using that word without knowing about collective modes, but he was talking of masses of excitations. Within general fields, he used the word fields, which was our everyday bread. General fields of activity without regard to particular nerve cells. And this is beautifully, because this is a collective modes, really. And this means that the neuron is there or not is not so important. And this Umezawa was stressing. I will go to Umezawa just in a couple of slides. Now, the dilemma was what sort of a nervous organization might be capable of responding to a pattern of excitation without limited specialized path of conduction. This is completely, you see, when today it happens that maybe not so seriously, but just for to make people understanding what is the situation in neuroscience, you find some neuroscientists that talk of wiring. Here, Lashley, one of the father of modern neuroscience, is saying that there are no wirings. There are no specialized path of conduction. It's not something like in an electronic device that if you cut it, everything is lost. It's not like that. Brain activity is something else. Now, the problem is almost universal in the activity of the nervous system. And here, there is opening to all biological system in some sense. Pre-Bram, he has been scholar of Lashley together with Freeman. Pre-Bram immediately when the idea of coherence in physics came out with the discovery of laser systems, immediately it was so natural for him because he knew a lot of things, not just neuroscience. And he worked out the analogy between the fields of distributed neural activity. The word distributed is crucial in the brain, and the wave patterns of holograms. And this was the start of the holograms, pre-Bram holograms models, or metaphora, as he by himself writes in some of his papers. So you see, we are with Lashley around 48, but of course, he was observing what he described in the dilemma a year before in his lab. And pre-Bram in the language Zebran, we are around 71, but even before, because of course, books came afterwards. Here there is Carl. And then, of course, it was so natural working with Emilio del Giudice, who was humanistically, how to say, permeated by humanistic views in science. It was so nice to organize a conference in Torino, also with the help of Mario Rasetti. And we edited together with Gordon Globus in Irvine, in California, in Carl Pre-Bram, and myself, we organized such a conference, and these are the proceedings of that conference. And the title was Brain and Being, at the boundary between science, philosophy, language, and arts, which was, in some sense, Globus was a philosopher, actually, and Pre-Bram, a neuroscientist, but with, so wide horizons to include philosophy, language, and arts. And so we came out with such. And Pre-Bram by himself, he was suggesting that the doubling of degrees of freedom, which is an essential part of the story, as I will tell you, the doubling arises, I'm reading this at the bottom of this quotation, the doubling arises from a natural duality. These are words by Basil Haley, a collaborator of David Bohm, and Pre-Bram, I had, could this doubling arise from a nature of the Fourier relationship? The Fourier transformation results in a complex number that represents both a real and a virtual line, a built-in duality. Of course, Pre-Bram was in some sense related with Gabor, out of which theolography came out. And the doubling he highly and Pre-Bram are mentioning here came from this comment on Umezawa's and Stuart Takahashi papers on brain, who pointed out that not only quantum, but classical processing can be derived from quantum field theory. This is a very essential point, because one of the main objections of a neuroscientist is that there is nothing quantum, which was what Freeman told me when I proposed to him to look at the model, the quantum model of brain. And he said, in my lab, I do not see anything quantum. But afterward, Freeman, who was Freeman, came to use quantum field theory in collaboration with the beautiful collaboration I had with him. And so there is such a transition from quantum to classical.
Professor
This is
Vitiello,
crucial.
25 minutes. Sorry,
Oh,
you said
already.
tell you.
So I just
take your time. Take your time.
Okay, so I will try to make it shorter. So and he was referring to Mezzao, of course, and okay, I did already publish the paper, and there is someone else in the story. But in any case, let me give you. This is Umezawa, and Umezawa, Ricciardo Umezawa in 1967, and then with Stuart Takahashi together, they wrote papers by considering the brain as a many-body system. And Umezawa was saying, in any material, in condensed matter physics, any particular information is carried by certain ordered pattern, maintained by certain long-range, you remember Lashley, long and Freilich, long-range correlation mediated by massless quanta. These are the Nambu-Goldson quanta in quantum field theory. If you look at to me, this is Umezawa writing, that this is the only way to memorize some information. Memory is a printed pattern of order supported by long-range correlation. And here starts the story of a quantum field theory model of a brain. And this is Umezawa, of course, the samurai that we know, a beautiful man. And then I have to jump about, but Umezawa, okay, let me say this, in one of his last paper, in some sense, development in concepts in quantum field theory in half century, dedicated to Eduardo Caianiello, who left in 1993. This paper is 1995, the years in which Umezawa also passed away. Umezawa was mentioning Freilich in 1968 with his papers, and Jibue and Yasue, which in 1992 proposed that spontaneous breakdown of symmetry in the Ricciardo, Mezzao, and Stuart and Takahashi model, the symmetry was the one related with dipole-dipole interaction. Dipole-dipole interaction was the symmetry indeed that in the papers I did show you before, born on the inspiration due to Freilich, we did publish with the Milano group. So here is water. What is made of the brain? If you ask to a neuroscientist, he would tell you about neurons, glia cell, dendrites. That is only just a few percent, just a few percent of the whole matter. The whole matter in the brain is 90% in number of molecules, water. Now, a physicist cannot forget about water. You cannot make forecast of in meteorology just forgetting about the sea and the clouds, just talking of air and the winds. You cannot, does not work like that. So water is the main actor. Water is what becomes coherent on the basis of a quantum field theory process, namely spontaneous breakdown of symmetry, and water, namely water molecule correlation, is the long-range correlations which tame the probability the wild probability, the randomness of a biochemist. So the source of the, now I am summarizing, of course, because I have to, that is the story. The water is at the basis of the high functionality of the brain. Not only of the brain, as I'm trying to tell you, but also of any biological activity. Because you do have biochemical activity. It's there. I mean, if you have if you go to a physician, he gives you some pills, something that is biochemist. It works. So it's not true that it does not work. Does not work. It works sometimes. I mean, most of the time, let's say. But why it works? Not just because of chemists. Because otherwise you might, I mean, your body or your brain is not so efficient as it is. Efficiency in the functional activity comes from the water background. That is the connection. Now, just to make it very short, these are quantum mechanics book with Hiromi Umezawa. And here I put, because this Japanese book, I know that is, my name is somewhere around here. I cannot read Japanese. This translation by Jibu and Yasue, who wanted to translate this book. I think it was 2005 or something like that, because the book was 85. So they wanted to translate in Japanese. And of course, I was very glad that then they explained me that my name was there. I believe it. And this is a drawing by my father. Just so you can see Pasquale Vitiello here. So Vitiello is there, at least for... but in any case, this book was the result of I was studying with Hiromi Umezawa for my PhD. And he was giving a quantum mechanics course, which comes inside of this book. So this is the story. Okay, this was dedicated, this issue, to Umezawa when he passed away. In fact, it's 1996. He died in 95. But in any case, here I just, I mean, I will jump, I stop here. But just let me tell you one thing. Yes, for example, this one. You see, this is quantum field theory. Now, water is coherently with short lifetime. The beautifulness of water is that water forgets. Please don't talk of memory of water. Talk about oblivion of water. If water would not forget, we would be crystals. We would not go through phase transitions. We would be not alive. We would be dead. So we are alive because water forgets. Okay, that is the point. But in any case, in that short lapse of time in which water is organized, you might use a quantum field theory mechanism like Higgs Anderson Higgs Kibble, I should say, mechanism, by which if you have a field like electromagnetic field to propagates in an ordered pattern, like water dipole-dipole patterns, it propagates through channels. So it is like if you want to cross the street and there is a crowd of people on the street, you have to make your way through the people. And the electromagnetic field makes its way through to water in some way, like in these drawings. Here you have the electric field going through this channel, which is a dynamical channel made by the field which pushes and opens the way. And then outside is zero, the field. Inside is non-zero. So you have transverse forces, and these forces are repulsive or attractive of any sort of dirty things you might have outside, like molecules of some kind. And then in this way, you create a coating of this channel, a chemical coating of the channel. Then, if you go to compute, just by using water property, nothing more, there is nothing chemical here, you find that the diameter, the inner diameter of this channel is 146 angstrom, which means 14 nanometers. Now, if you look at a biology book, that is the inner size, inner diameter of microtubules. Everybody talks about the microtubula because practically all the metabolic activity happens along a cytoskeleton in the cell, which is made by microtubules. Now you have here, we had in 1986 in this paper is such a computation, is very easy computation. You have just on the basis of water, you have that this channel is of this size. And then you find the dynamical construction of microtubules. You see, the water, I mean, crucial, above all, importance. And you find, in fact, from this propagation, the damped propagation of the vector potential in the electromagnetic field. You see, it's damped through this quantity. It is compute with quantum field theory, this business here. And this M is given by these numbers. And here, everything, you see, there is nothing. There is electron mass, epsilon 0, which is the electric constant, the charge, which is twice the electron charge, the density of polarization in water, N is the number of dipoles. So how many dipoles you have? If all of them are oriented, N is an Avogadro number divided 18, which is the molecular weight of water. And so if you put together these numbers, you find that D, the inverse of M, is 14.6 nanometers. The observed value is between 11 and 15. So you see the dynamical construction of living matter. Once you have a microtubula, you will have a biological biochemist activity. This is the idea, the dynamics underlying living matter. So, all of this, of course, is there because you have dissipation. If you close a living system, you kill it. If you close a brain, you just, the person gets crazy, lose, and consciousness, okay, this is doubling, but there is no time to go on that. Consciousness comes from this dialogue between the brain and the environment in which it is embedded. The environment is what for divulgation, talking with biologists, you cannot say, use many formulas. You say, okay, I call it the double. Each of us has its own double, which is the world in which each of us is embedded, immersed. And we talk with this double. This talking with our double, which is a dynamical process, also this one, our interaction with the world is a non-linear interaction. Life is not easy. It means that our interaction with the world is non-linear. The world wants to change us. We want to change the world. We have to come at some moment to some kind of agreement. In such a dialogue, on such a bridge, that one is the consciousness act. So consciousness is the result of the functional activity of dissipation. Because the brain, if the brain would not be dissipating, would not have any double. We would need there was no reason to double. This A tilde is doubling in mathematical way the system AK. So this doubling was the doubling that Umezawa and Takahashi, they did already in terms of field dynamics, namely quantum field theory at the finest temperature. But that was a great suggestion when I knew through Pribram, Frederick, and all those people that I could not talk of a brain if not as talking of a dissipative system. Then if I have a dissipative system, I did study already at the time with Celeghini, Enrico Celeghini and Mario Rossetti, and the paper is on Annals of Physics, 92. And then I exported, in some sense, applied to the brain modeling such kind of doubling. This is the doubling of which Pribram was talking. And here, the consciousness is in the talking between A and A tilde, between each one of us and the world. Now, that world is inside us because we construct an activity of the brain modeled on such a double. That construction is the mind. We know what is a brain because the brain is made by matter. But what is mind? Mind is the double representation that in the brain works to recall to us how to do something. So mind is related to the intentionality. Pribram and Freeman, they were always insisting on the intentional actions. We always move in the world with some intention, to do something, with a task, with a plan. How do we realize that? We go back to our previous experience, to what the double has been teaching to us. This is why the double is mind. And the double suggests to us how, for example, how I should do to stop it, because I need to stop, otherwise all our meeting goes away. So really, I stop here. Okay, thank you. Sorry.
No, please don't apologize. Thank you, Professor Vitiello. I really didn't want to interrupt you. You insisted to tell you when
No,
25 minutes
absolutely.
is up. This was really beautiful. I'm so grateful, and I loved how this is a very hard topic, and for the first time I really understood some particularities of this just because of the way you explained things. So this was in many ways eye-opening for me. I'm always sorry that whenever we do these webinars, we cannot give an applause, but from me at least.
No, it's okay. No.
So we have several questions in the chat box, but if anyone wants to ask something, you can also raise hands. I will first start with the questions which are already in the chat box. If you're ready, can you, or do you want to, you ready, Professor Vitiello?
Yeah, I can read,
Okay.
but it's not better if, okay, how negative frequency, I'm reading the first one that appears, I do not know.
Yes.
Oh, this is by Nishiyama, yeah.
First is by Pierre.
Yeah,
so,
non-negative frequency in environmental Hamiltonian appears in total energy. Negative frequency means that negative infinity number is a minimum point. It is problematic. Okay, thank you very much for the question. In fact, you see, there is no such a problem because we need a balance between the open system. Now, just think in terms of general, also the brain, of course, and the biological system. But for any open system is a system which can exchange energy with the environment. So in any energy, information, whatever matter. So in any open system, what gets out of the system comes in to the environment, and vice versa. So when you have to write in formulas these things, you have a product, E times T. E is energy, and T is time. So to change out into in, if you look at the other one, the environment, you have to change the sign of time. But this is equivalent to change the sign of energy and letting the time go the same direction. So in a very natural way, you find this minus, which is here in this formula, maybe you see. It comes from the energy flux balance. This is because you want that the number of things here, Na is an operator number, forget about, but the energy, if you multiply by h bar omega, the energy getting out of the system has to be equal, this minus put on the other side, and has to be equal to the energy that the other system gets, and vice versa. When you put all of it on the same sides, you get this minus. Because in a balance, I mean, if we talk of money, it's immediately clear. If I go to vacation and I went out with 1,000 euro in my pocket, and then when I go back home, I found 700, I say, where are 300s? Then if I have a red pen, I write 300s in red. And because it's what I lost. But that loss went to somebody. And then I need to balance my 1,000. So there are 300 in green. 300 has to be in green to equal to 300 in red. Otherwise, something is missing. I must balance. So this is now it happens that this when you write the let me see, when you write the Hamiltonian, that minus comes here, but it happens that this object is the Casimir operator of the SU11 group, because these are bosons, which means is an operator which commutes with all the generators. So once this number is fixed and is 0 because we require balance, then there is no problem of it is lower bounded. There is no problem that this might become a minus. This is the beautifulness of the group theoretical structure of this modeling. This way, right? This is the equation for the energy in terms of field dynamics by Umezawa, based on Araki papers. Takahashi and Umezawa wrote the thermofield dynamics paper in 1975. This is the same Hamiltonian. And this is the generator that lets you go from one number to another number, generates the state, which is the memory state in this case, but it is the thermal field theory state in the Takahashi and Umezawa paper. So all of it is consistent. You do not get never negative energy. It's just in terms of balancing the quantities. Because when you consider the dissipative system, you need to consider all together the system and the environment.
I think, do you hear me?
Yes, yes.
Yes, yes.
Okay, okay. But this equation 2 is very simplified.
Yeah. In fact, that is also a beautiful
another
aspect.
interaction term will appear, some kind of non-number conserving terms.
Yes, yes, there is this object here, you see? This generator, here you created scalpel, and this creation has to be equal to destruction. Always couple.
Okay.
So this means that you do not have, thank you for this question. This means that the ground state for this Hamiltonian is not just one.
Just one, okay.
But there are infinitely many. And this was in the next page. You see, your total number, you might define a code, let's say, which is memory code. Let's call it N. N is made by NAK, always equal to NA tilde, because of that Hamiltonian, at any time as it was at the time equal to 0.
Okay.
Now, your state has an index N, here, if you see, and this index means that this N is, you see, when you have the difference, if I say 7 minus 7, that is 0. But also 5 minus 5 is 0. But 5 is a different code, is different memory.
Okay.
So I can have infinitely many just because there is a freedom in the theory. This freedom is the freedom which quantum field theory gives to me, because I have infinitely many vacua, representations, all of them with n of a equal to n of a tilde, for any n. So infinitely many. This is why I, in the title of my original paper, I talk of memory capacity. You have an infinitely many memory you can collect. And this you have only if you do quantum field theory. In quantum mechanics, you cannot do that because you have only one representation.
Okay.
Nishiyama Sensei, does this answer your question?
Yes, but additional, I want to ask additional questions. And external neural stimulation by external electromagnetic field or ultrasound or photonic interaction, and incidental photonic beams might change this ground state.
Yes, does it?
Yes.
This is the original proposal by Umezawa and Ricciardi. The stimulus coming from outside breaks the symmetry, which means carries you from one state to another one. The other one is unitarily non-equivalent. So it is a novelty. You learn something. And to do that, you do not need a strong stimulus. Even a very light stimulus can produce such a change. And this is beautiful because mind has to be always ready to different situation, changeable situation in the outside world for the survival. And indeed, Walter Freeman, he found, and in this model you can show that there is in the model, I didn't know, but it was there. Walter Freeman, he has been, I think, the first one to show that in the brain there is a dynamics of chaotic, deterministic trajectories. So there is chaos.
Chaotic, deterministic chaos.
Yeah, which looks like a contradiction in terms, but it means that a very slight input, which you might think of to be initial condition, determines a new trajectory. Okay. Now, suppose, Yelena, that your phone is vibrating. I do not say ringing because maybe you close the ring, but it's vibrating. You are thinking and talking with me at this moment, but that vibration, you feel that vibration. And you might even choose to look at your phone. And this is chaoticity. Because you have different trajectories. And they diverge with a Lyapunov. Indeed, you can compute in this model. A Lyapunov exponent, namely the degree of divergence, how much they diverge as time goes. And this is crucial. This is a very efficient situation. Because suppose I live in nearby Salerno. Suppose that after this talk, I get on the street to buy something or just walk. And I cross a nice lady like you, just like you. I said, but how is possible? Elena she was in Japan, or I don't know where are you now, but it's not possible she is here. But she looks just like you. So if there is no such chaotic behavior, these two trajectories, is Elena or not? Is Elena or not? It will persist up to when I came back home and I call you, Elena, you were one or not? But if just a movement of your, of that lady, I don't know, lips or eyes, is slightly different than yours, then that small difference brings me on a divergent trajectory. And then I say, I see, she is not Elena. So this is extremely efficient.
Yeah,
Chaos is not a distraction of determinism. helps
Yeah.
the therapist.
Yeah, we see this in water very often.
Yeah.
Thank you.
Yes.
You see, exactly. I mean, this happens because of water.
Yes. Yes. We see it. We see it very, very often. Exactly what you say. Very small, very tiny influences on the water structure change the spectral pattern. And you're talking about pattern and memory.
Yeah.
Mm.
There is a beautiful paper by Walter Freeman on Scientific American 1991, I think, or something like that, where dedicated to his discovery of a chaotic behavior in the brain activity. It's a beautiful paper.
Thank you. Thank you for this recommendation. Well, I believe what we were just talking, and when Professor Tsenkova commented, this actually answers one of the questions which was posted by Professor Harold Martins. He said, then do consciousness changing chemicals like anesthetics, dopamine drugs change the aquagram of water when added to physiological water? So the answer, I think you now heard, Professor, they certainly do. We saw that in aquagrams, and obviously the chemicals do influence this water organization, the structure. That is why we can see that in aquagrams. So this was probably not so much question for Professor Vitiello.
But is very important, because we always have to think how this physics has a biochemical consequence. Once we change the environment of a dipolar structure of the water through one of these actions, then the biochemist will change.
Absolutely.
You see, so it is correct when a old-fashioned, but they unfortunately they are almost all of them old-fashioned. When an old-fashioned biologist said, "I do not see that because I give I don't know which kind of chemical compound, and the person does or not does something I want." That is correct. It does, but because at the background, that kind of drug changed the dipolar environment of water. Then all the probabilistic, how to say, the probability, the randomness of a chemical reaction change accordingly. In a very complicated way, by the way. I mean, it's not easy. But if you change the polarization of the water, you change the chemist. Not because you are changing the chemical substance, because you are changing the probability that one chemical molecule meets or not meets, reacts or not reacts with another one.
Yeah.
So it is always crucial to move from this physical to chemistry.
Okay, we have Professor Martins. You can say if you want, just join because this is a nice question.
Yeah, so you know, I am an old man and I have believed so many things in my life, and I've had to change so many things in my life. So I don't want to take yet one more salto mortale. So I'd like to know whether the and I'm an empiricist. I'm a biochemist by training, and then multivariate and data analysis, statistics man, and cybernetics man. So question is, in the aquaphotomic observation of strange effects, have they been seen with unquestionable statistical significance so that you can publish in Nature or Science based on rigorously designed experiments? Because I'd like to see this be published at a very high level and be started to be more accepted.
Of
course. But then it has to be very, very scientifically well founded. Otherwise, the opposition will just kill it.
Yes, absolutely.
Yeah.
Well, who wants to answer? Professor Vitiello, Professor Tsenkova, or I can also answer?
No, just a comment on what Professor Martin said. I agree with you, but because you see, it It depends on what is the object of your observation. Now, very few people have paid attention in biology to the role of water. They pay attention to the role of water as a solvent. But water is an actor. That is a conceptual difference. So if you make your experiment and you think of water as a solvent, you just forget about water in your conclusions. But if you do not think in that way, you change your mind and you look at what water is doing when you do your chemical reaction, then you will find that that depends on the polar potential, dipolar potential, in which you put your ions. This is electrochemistry. So much is due to, how to say, the protocol of observation, including or not. And we do need mistakes. Because if we always work within what is known, we are at most experts, but we need explorers. We need Colombo, Cristoforo Colombo, not because in Italian, just because chemistry enough. The discovery of the states, of the America, not the states. It was Colombo. A mistake. It was a mistake for the geographer. The same Colombo, he thought that was India, and he called the people Indians, but they were not from India. So only through mistakes. And mistakes, in Italian you say errare. Errare means moving around without any fixed direction. Just wandering. We need to wander.
That sounds much more positive.
We need to, you see, Hiromi Umezawa, he writes in his talk, I think when he was, it was for his 70th birthday or something like that, I can find it. He wrote that he was a lucky wanderer. Now, listening at my Prof. Samurai, you would not make a mistake with Umezawa, otherwise you would cut your hand, but then I'm embracing you like a son, that he has been a lucky wanderer. That was a big teaching to me. You must look where nobody looks.
Yes, I agree.
You must be explorer. A scientist is not the expert. The explorer must carry with him, in his backpack, all the libraries of the world, all the experts of the world. But when he does exploration, he must forget about what is known. Otherwise, he cannot see what is there, and he will not recognize the novelty.
That is really beautiful. And now you just, I had an association. Even the word scientific research, it means research, repeat the search. So,
No, I would not say that. I do not know if it's correct, the etymology you say. I
don't know. It just was like, oh, maybe that is why we're called researchers, repeatedly searching.
No, I don't know, but I think it's much more near to errare. Making mistakes. Wondering.
Going back to Harold's question, Harold, we are on our way, I think. So we've published quite a good number of papers, I think, showing that water is a mirror. Water is the mirror, exactly what Giuseppe was talking about. And it is the ultimate sensor, because water as a dipole interaction gets influence from the environment. And we show this with sound, with temperature, with light, over different various systems in a number of papers, showing that water changes even with subtle perturbations, very subtle perturbations. And I agree with you that we need I can't imagine that we need one paper that will just, no, we just a sequence of papers that we show this on our way, exactly that the water is the mirror, and the dynamics of the water structure is the source of information that we need, and that the spectral pattern, which we talk about patterns of as the information storage, it is what we prove in our papers.
Maybe I can add, I mean, we worked on it and there will be paper published soon, but one of the works that we did recently was exactly with what you said about consciousness changing chemicals with anesthetics and their effects on microtubules. So we're currently working on that. So you can probably maybe in a few months see at least that paper, and it would be very nice if you can, you know, like comment on the, you know, like draft of the paper and what we can do maybe to help, you know, better experimental design, you know, really make it with unquestionable statistical significance so that it is really rigorous.
Absolutely, yes.
May I, sorry, may I go back to Professor Martens? He was asking about observation of this water, how to say, activity, moving, controlling, in some sense, biochemical activity. You see, I'm not a chemist, neither a biologist, but I know that if you are in a lab and you have some kind of a chemical reaction, not only of a biological nature, but suppose you have a biological nature, you have to put that stuff in water in such a way, if it is a protein, for example, will not be destroyed. We know that DNA without water does not works. That is known. Every student knows that cannot take out all the water from a protein chain or DNA. There is always some hydration water. Now, when one does in a lab experiments of chemical nature between biomolecules, you put in a liquid, which is a liquid where those substances survive. That liquid is, of course, of a definite pH, of definite purity. If you change just slightly one of those parameters in the liquid, in the, how do you call it, in this broth in which you put your things to make them react, if you change that, the reaction change, or does not happen, or happen something else. I don't know. But that is the reason, because that liquid is mostly water. If you polarize with some artificial tools, some electrical field, or you put some magnetic field around, you will have different chemical reactions. And those chemical reactions are the instrument, let me say in this way, through which you observe what water is doing. So since we do know that some chemical act, I mean, in medicine, on our body, also according to a general state of our body, this is a very complicated chain of steps, of course. But that again suggests that 70% in weight, but 90% in number of water molecule is doing something. But in a lab, one can do a very easy experiment, very well-known reaction between two well-known chemical, biochemical substances, whatever they are. And know that they act in a special way that we want when they are in a soup of very well definite parameters like pH, density, impurities, whatever, temperature, and so on. And then we do the experiment as a control, and we see that it works. Then just change one or more than one of those parameters of this broth in which you are doing your chemical observation. Then you will find that unless there is a wide range of activity in those parameters windows, then, but if that range is not so wide, I mean, if it's very much sensible on pH, let me say, or something else, then you will find that changing that parameter in the water, your reaction does not occur. And this means that you are using your reaction as an instrument to observe the influence of water on the reaction. But I think that this those happens. Only that at the end of the day, you do not report in your note that because the water was just a solvent. Just a solvent. So you forget about the solvent.
Yes.
But if you put everything, you see that the water will not. Okay. Oh, hi, Vladimir, you are there.
Please,
nice to see
Professor Voikov.
Giuseppe, I was just fascinated by your talk, and I suppose it helps me to understand one miraculous observation, which was made by people who are using tomography, nuclear magnetic resonance studies of human brains. There are I was told by such medical scientists that there are such very rare cases when people practically do not have the morphologically organized brain. That there is, of course, brain tissue near the skull, but the major volume of brain is just water. And these people, they have consciousness. They are not geniuses, of course. They are not extremely clever people, but they are not ideas. They are just people, you see, not animals. And from this point of view, you see, we pay so much, it seems to me that we pay too much attention to morphology of brain, to biochemistry in tissues which we extract and in homogenate which we study, and we do not pay so much attention to holistic problems, to fields, because what is, from this point of view, brain is a field.
Yes.
And it is what a field. And of course, under normal conditions, all this cellular structure is supporting it. You see, it keeps its stability and optimizes all the reactions and so on. But when something is wrong, and there are a lot of examples when people were just hit, their brain was partially destroyed, and still the people stayed the same after this partial destroy. Of course, it is a rare case, but such rare cases should be also explained from the scientific point of view, and not to be just surprised. Let's forget of such cases, because this is 1 for 1 million. This is one which exists. And it seems to me that your approach, your, in fact, field approach to just consciousness, to holistic problems, it may explain starting from these exotic cases to just normal activity of brain. That's one point. Another point which I wanted just to mention, I was waiting that you would mention Alexander Gurevich. His
yes, of course.
Biology field. As a matter of fact, Gurevich, he wrote that it is very wrong to apply to the central nervous system the laws or the processes which are characteristic of neuromuscular transmission of neural impulses. For him, brain was not, as you said this exactly, that this is not just connections of one cell to another, to third one. It's not a network of electrical network of cells. For Gurvich, it was a continuum. So the excitation in brain was moving irrespective of cells. You see, cells were just like a substrate, like waves in the ocean, in the lake. They are not just directed movement of particular molecules of water. This is the holistic movement. And yes. Gurvich was just trying to show that this is the field approach can explain, or at least it should be the root for explanation of the consciousness and activity of central nervous system. Thank you. That's what I want.
Thank you. Thank you, Vladimir.
Professor Voiko.
Yeah, thank you very much. You see, what you are saying about Gurvich, maybe one could think in terms of entanglement, which is toward the popular word, although Schrödinger introduced it in 1935. Entanglement means in-phase correlation, which means that long-range correlations we started with. So it is exactly that kind of dynamical, you see, phase correlations, they do not need a messenger. They are in phase, like in an orchestra. The violin in a large number of people orchestra, Boston Philharmonic Orchestra, or I don't know, another one of more than 100 people. The violin in the third line of the orchestra is not forcing the guy upstairs to 10th row to play at some moment just by forcing or sending a letter to him or in a WhatsApp as it would happen today. No, they play in syntony. They are phase correlated. That phase correlations is not a violation of relativity because it's instantaneous. One would think you need enormous speed, higher than speed of light. But it's not so because there is no transmission of messages. They play just as one single person. So this is collective motion, as you were. And I think that that is a very important step. But it's a step that Gurvich was so much before all of such things could happen. But once you write, let me see if I can get to the form. Yes, maybe. No. Oh, yes. You see, this is the state of T. Can you see the screen?
Yes.
Yeah. You see, on the second line, there is this symbol, which is a symbol for the state of a memory of a code N. N is a collection of N for each every K, so is a memory state. Now, this state has this shape. And in this state, there are A and A tilde together. Now, it is, you can show formally, mathematically, I mean, that A and A tilde are entangled states. But A tilde is double. So this means that the modes of the brain is entangled with this mode representing the environment, which at the end of the story in 1916 with Walter Freeman, we identify with mind, what is usually called mind. So there is entanglement. And here I find, if you want, a mathematical formalization of Gurvich experiments, because he was watching at the cells related each other, even if separated by any electromagnetic fields. I mean, there were no any field of connection between them. Nevertheless, they were reacting accordingly, I mean, like just one object. Yeah, thank you very much for this observation.
Thank you, Professor Voiko.
Thank you.
Do we have more questions?
Abe Sensei.
Right.
Yes, please. Yes. You have a question.
This is not a question, but just a comment. Actually, I have two comments. Firstly, you mentioned something about chaotic dynamics, deterministic chaos. But if the system in the strongly chaotic state, then it quickly forgets its initial condition, because it's very sensitive to the initial condition. So therefore, my naive intuition is that the chaoticity is rather weak, so near the edge of chaos. In that case, the system remembers its initial condition for a very long time. But in addition, there appears a new behavior that the two different trajectories does not diverge exponentially, but much more slowly, like a parallel. But inside that envelope, you have a large fluctuation, which may correspond to your wandering. Is my first comment. And the second comment is about your scheme of doubling. So you go A to A and A tilde, but I'm rather interested in the opposite way. So we start from A and A tilde to A by removing A tilde. Okay, then the question is, if the total system is reduced to the original one, A, then does subdynamics of that degree of freedom still remember its initial condition? And this is this could be related to the concept of memory. And mathematically, there is a nice theorem proved by Denis Petz in Budapest. For certain closed unitary dynamics on A and A tilde, even after reducing A tilde, still this subdynamics is reversible. So you can invert. So therefore, the even subsystem can remember its initial state, or it has a memory. So this is a nice structure of Umezawa and Takahashi and Umezawa, which has not been noticed well. Those are my comments. Thank you.
Thank you, Abe Sensei.
Thank you, Sumiyoshi. Okay, what you say is beautiful, and let me consider the first of your points, namely that chaoticity might contrast memory, persistence of a memory, in the sense that would wash out. But nevertheless, within a domain, you do not have any more divergent trajectory, but within a domain, you have fluctuations of a trajectory. This is very nice, because this is the role of what we call intuition. When I'm talking now with you, my mind is going when I was talking with you other times in Japan or here in Italy when you were visiting. And these fluctuations, which are in my mind in this moment, are those fluctuations of the trajectory you are talking. Because I should say one thing. You see here, unfortunately, is on these slides. You see, a memory state of T with some code of memory at time t, and this was at time 0, goes like for t going to infinity for large time, provided that the summation of this quantity is non-zero, then it goes to 0. This is forgetting. A memory has been forgotten. This depends on this k, but this gamma, they are model dependent, namely are brain dependent, depends on spatial parameters, real anatomical, I would say even parameters. So at the time t, the largest, here is for each k, but for the largest one, t equal or larger of theta over gamma k, namely when this object here is 0, then this is washed out. So memory is lost, which is expressed in this way, yes. So the brain in this model can forget. And this is crucial aspect because our relational activity in every day is based on the fact that we forget what we just said 1 moment before, otherwise we cannot drive a car. We need to go on. After the bend, we need to go straight or to make a bend on the other side. So we have no time to remember what we did just 1 second before. So in our relational activity, in fact, that is short-term memory, the relational memory. And that is essential for our everyday, survival in the world. It would be terrible if we would remember all the words we are saying when we talk. We cannot talk anymore. This is on the first aspect. So how this is smoothed out, if you want longer, it depends on gamma, but also depends on the fact that really these representations are the non-unitary equivalence is only approximate, because there are a finite volume effect, there are impurities effect. So this makes such representations a little bit unitary. You can go from one to another one just by smoothing out this non-unitarity. Otherwise, you will be trapped in one of them, and which is a pathology, by the way. Being trapped in just one memory. Fantastic. Or just one idea. That is a pathology. So we do need, nature is beautiful because nature follows mathematics, but smoothing out, how to say, rigidity of mathematics. And so it makes us a fancy way of living. And those, and that has to do with intuition. Before we were talking about etymologies. Intuere, it means to look inside. So we are able to look inside ourselves. And here I came to your second question. When I met Freeman, he told me, look, you say that you, Umezao and Ricciardi, you say that when an external stimulus impinges on, I'm captured by some external impulse, then my brain changes. There is spontaneous breakdown and a new state is created. And I memorized the states. But I did this experiment. I do not have here the slides, but he did an experiment and with his cat. Actually, it was the cat which I met once I was visiting him, of his wife. And he did the experiment. He put the cat. First, he did not give to eat anything to the cat for, let's say, 1 day. So the cat was hungry. He put in a box without isolated from any kind of smell from outside. And he did the electroencephalogram to the cat. And then he opened a small window and let a flow of fish smell going in the box. In the electroencephalogram, you see that at the moment of opening the window, the brain of the cat was, oh, finally I get lunch, was reacting. And so the external input produced the reaction into the brain. But then he did let the cat eat enough. He was satisfied. Then he closed the cat again in the box. And again, isolated from any smell. Again, he opened the window. Again, the smell of fish. And the electroencephalogram did not change in any way. The cat was no more interested in fish because he had the lunch. I mean, the brain reacted to the same stimulus in two completely different ways. So this is something in which you have decoupled, as you were saying, A tilde from A. And you get only A at that moment, only the brain of the cat, who was not considering any input from outside, anything from the tilde, the environment. You see, this might describe more or less what you were saying. So this means that the brain has its own dynamical working, which might or might not be influenced by the external input. When it is influenced, then you have such an entanglement, A dagar, A tilde dagar, which is here in this equation, number 7. When the brain does not need, there is no intention to talk with the environment, then you do not need this coupling. And the brain has its own activity. This is what we do observe in physics in many materials. But the possibility to switch from a situation in which you have this interaction between this couple to one in which you do not have, this is another beautifulness of the brain. Namely, would be here not on O of n, but just on the vacuum for this. Sorry, I was looking on this the vacuum, the origin, not this one. Okay, an original vacuum, the one on which these operators give you 0. Okay, I do not have, do not know where are, but okay. So this is possible to do. Thank you. Yes.
Thank you, Professor Vitiello. Okay, we really extended the webinar a lot, but let's if anyone has, I think we can have one more short question. If anyone wants.
There are a few questions from Pierre.
Pierre.
Yes. How can I squeeze the information content into the Hamiltonian?
Oh, yes, I see. Here there is, this is a very interesting question because our world today lives on information. Information is something, is a god. Everything is information. But there is a point which is essential when Pribram and Freeman, this is Freeman, Walter Freeman. When Pribram and Freeman, they were talking of intentionality. Somewhere I have this, okay, somewhere. They were saying that there is always a choice in the action we want to do. Before Elena was choosing to talk with me instead of watching at her phone, vibrating phone on the table. Elena, I'm using this as an example. Maybe there was no ringing of your phone, but it doesn't matter. So Elena chose one input from another one. She was decoupling a specific A tilde in this formalism from it's her interest, let's say, in doing something else. And then this allows to have intentional actions. We do something because our intention is, so they were saying there is always an intentionality in our activity, in the brain activity. Now, how this can happen? This is not run by information because the ringing of the phone and my voice or her voice are both information, but we choose. How we can choose one information which at that moment is less important than another one, or more important than another one? Because the brain constructs meanings. We have a transition from syntax to semantic. The brain constructs in an abstract nonlinear dynamical system a landscape, an attractor landscape of attractors, a landscape of attractors, namely of states representing an experience in the perception life of the brain. So the story is made by such a landscape of attractors. Now, the relation between the attractors constitutes the meaningfulness of the whole landscape. When we came to know something else, something new, we go to look in our landscape of attractors to recognize something which we already knew. If we do not find anything like that, we construct a new attractors. But this change the whole landscape, the whole scenario. Any new acquisition is not like adding one more item to a list, like in a dictionary. No, every time we change our view of the world, we came to understand something else, which led us to understand in a different way, better, or completely changing our understanding of what we thought before in our vision of the world. This is based on these relations between our knowledge. In the previous experiential life, with respect to that which happens at that moment. So the brain always constructs meanings. Just one moment, I have usually memory recording is always formation of meanings. Maybe you see these slides. This was memory is not recording of information. Memory is formation of meanings. This is a crucial aspect, which is, it tells you how far is artificial intelligence for, what means artificial? Artificial means non-human. How far is artificial from human? Human brain constructs meanings. That is the real point. Informations are not very important. They are important as far as we can attach a meaningful correlation to that information in relation with other things. You see, this is the intimate mechanism of what in neuroscience they call action-perception cycle. A perception is related to an action only if it is meaningful for us. If I do not care about the ringing of my phone, I go on my action, which is a different one than just looking at the phone. So there is always a meaning that we associate to information. And this is how we squeeze. The word squeeze is very interesting also because it's a technical word. Because that state I did show you, it is a squeezed, generalized SU11 state. But the squeezing here means how we bypass information, how it happens that some information becomes for me so important, so meaningful, that it creates an emotion. I can see many faces but so many information, more or less always with a nose to eyes, ears, and so on. But some of that phase create emotion in me. How it happens? It happens because some of that phase are meaningful to me. Or they remind to me something which has been of some importance in my previous life up to that moment. And this is a crucial aspect. From here, you go to open your horizon to ethics, to aesthetics, to philosophy, to arts. That's the title of the book with the Carl Pribra.
Yes.
Yeah. You see, so knowledge is just one. Knowledge is not mathematics or poetry or literature or physics. No, it's just one. Our brain does not know physics. Knows meaningfulness, the pleasure of doing physics. That my brain knows. Does not care about Newton laws, but it cares about the beautifulness of seeing something falling down.
Yes, this is really what we're now talking is really beautiful and so applicable to so many things, like, why mindfulness matters, why we do meditation when we want to change we say it, brain patterns, the way we react, why traumatic memory is so persistent and so on. And this is really beautiful. I love when I have so many things explained, but I cannot believe that the first time I heard it from scientific, really, like coming from equations. And then, yes, I had this aha moment when I was just listening to you now.
Aha moment, that is it. Yes, I put this in slides like this one you have now. The vision of the world, the intentional search of situation. Yeah, it was meant to tell you, but thank you for the questions, of course.
Okay, shall we have one more question or comment if anyone has? Professor Tsenkova, perhaps? Pierre really had some more comments. Information is a difference that makes a difference, which is really like what you said about the meaning, which is really beautiful. Pierre, Paolo Renati agrees with Pierre about that. Well, I think we are about to come to a closure of one of the, I think, really most wonderful seminars. I have to say on my part, first, I did not understand many things about your work because I was relying on interpretations of your work from someone else. And now I see that I absolutely agree with what coherence is with you and not with how other people interpreted that you say what coherence is. And I loved it. I absolutely loved it. And I loved about your talk that you, this is the first time that I heard how you insisted that biological matters live only if it goes through phase transitions. And this is something that I saw from our data, from experimental data. And last year at the water conference, I even, when I was showing these aquagrams, I presented this part that we see when we see liquid phase transitions on aquagram. I said that this is the heart of water. I even put a pump because this was for me what life is. And you said afterwards that water forgets. This is something really for the first time I hear everyone insist about water memory, but this is exactly what I love, that we have this phase transition. And due to this phase transition, if there is not such thing, we would be structured, we would be crystals, right? But now I have a one little question. What about time crystals?
Thank you. You see, time crystals. Okay, I think that meaningfulness goes very deeply in our being. So we have some experience which sometimes has been really meaningfulness for us. And if some boundary conditions happen to be something near to those conditions in which we had such an experience with so big meaningfulness, meaningful content, we go with our mind to that time and we feel to be in that moment again. This is like moving on a crystal of time. Because a crystal of time is, after all, and now is the log you were mentioning, is a self-similar structure. A crystal of time, it means that you have a lattice which is repeating. So you have a self-similarity. But self-similarity means that you do not have any more a scale. Because you can make, you can look nearest, you can zoom in or zoom out, and you see always the crystal.
That's right, yes.
So this is what happens to us when it looks like or we have been here, or we do remember exactly that we have been there. We go back by zooming. I always make an in or out, I do not know what, making, enlarging, let's say, enlarging, and we find ourselves exactly in those places where we have been. For example, when this happens, especially, you see how the fact of meaningfulness, meaningfulness relates to qualitative. So when we taste an ice cream, I say an ice cream because when we taste an ice cream and we remember, oh, but this ice cream is like the one I had, and how I can compare two qualitative feelings as a flavor of ice creams. Just by zooming in such a way, in such a way, it is like I'm tasting the ice cream I had yesterday. You see, when we recognize a flower, this is like, and then we say something, I don't know. You are eating spaghetti, and you are not in Naples, but you are, I don't know, in Paris. And you say, but this is like the ones I had in Naples 2 years ago. You feel flowers that you had in another moment. So you are moving in a self-similar manner in time.
Yes.
You see? But this, of course, depends on your meaningfulness, on the meaningful association that you did with such flowering. Otherwise, at our, how to say, stage, but even at the quantum stage, we do not make a distinction between the granularity of time, not yet, at least. So time crystal is in this frame, at least, is like a fractal structure of experiences.
Interesting. Really interesting. Thank you. We had just 2 comments. I will read them, and then I am afraid we would really need to finish. But the comments are really beautiful. First, from Paolo Renati, that we could just see that mere alive biological system being ordered in time, being a coherent process, existing as a continuous flux of phase transition, is indeed an aperiodic time crystal, which I really like. And from Professor Giuliani, who is here, Professor Giuliani, he was quoting on from Emilio Del Giudice. He said that true is beautiful since understanding is an aesthetic emotion. Indeed, in the Pepinus perspective, if I understood right, understanding is to build meanings that in turn become attractors for new information, which is also very, very, I think, beautiful. Yes. I'm glad. So then I'm afraid that this has come to an end. We were like 2 hours, but I warned you, Professor Vitiello, that sometimes discussions become really longer than the lecture itself, and it inspires people to ask and comment, and so this was very beautiful. I'm very grateful for hearing you speak. I really missed actually hearing you talk live. I've only had once this pleasure of hearing you, and obviously I really needed to hear from you again, not just from the papers, because your papers, unfortunately, because I'm not a physicist, are quite hard, difficult to understand. And we have now in our lab Nishiyama-san, who is also a physicist like you, and we also have a trouble understanding equations, unfortunately. But when I hear you speak, this is really this has been the language that even an ordinary person like I can understand. So this was really very life-changing, I think, for many of people here who attended. So thank you once again.
Thank you.
I hope we can meet again. And I have one information about the next webinar. Of course, so I have to first say about this webinar. The recording of the webinar will be available in just a few days, and I will probably return many times to watch again. And if English is not your native language, you can also use translation on YouTube in Japanese or other languages. So this is a very, very good advantage of YouTube. So it will be just in a few days. If you have further questions or comments, you can, when you see this video on our Aquaphotomics channel, you can comment and ask there too. So please just, wait for a few days for the link. We will send to all of you who attended the webinar. We will send the link to the recording, and you can share the link with other people. You can comment in these sections, and we can continue discussion. Of course.
Just a few words.
Yes, Professor Tenko.
Sorry.
Yes.
I would like, Vitiello, first of all, thank you very much. It is exactly what I think we needed. And we started something very, very promising, I think, and something that we should continue. I would like to ask you for the presentation as well, so we can upload the presentation together with the video. And let's think about, so Jelena will announce the next webinar in a line in this direction. We couldn't talk about holography this time. We don't have enough time. I hope so we can have a kind of series of these talks, and let's continue. Really, thank you very much.
Yes.
Yeah, Elena, go ahead.
Thank you. I'm very, very sorry. I would like to share my screen now, but I love what you just, Vladimir Voykov. Yes, applause for Professor Vitiello.
Yes,
I totally agree. So I wanted to say, Borges is one of my favorite writers. His poem Tiger is one of my favorites for all time. I like what you also presented here. But unfortunately, I would like, can you please now close the screen so I could share the announcement of our next webinar. Our next webinar is actually going to be a very, very, let's say, continuation. The topic is going to be very similar, and it will build upon what you talked today. Can you see the slide?
Yes.
Yes.
Yeah.
So our next webinar is going to be held by Dr. Joachim Kepler on 27th November. And we're continuing with the consciousness. And now from a little bit different view, from a different person, we will see the role of the brain's neurotransmitter water matrix. So we were going deeper into this. So thank you again, Professor Vitiello, for sharing this talk today with us. I think many of the people enjoyed. I really have no words to describe how wonderful this has been today. And thanks to all the attendees. I'm so happy that so many of you have come to listen to this wonderful talk. And because, you know, we as a scientist, we have to really pay large prices to attend conferences and so on. And I think we have been really lucky that we had this webinar to hear this man. I'm I'm so happy that all of you could have this experience. It's not just me who attend the conference and come excited and oh, you know what I heard from this. And so I'm so happy that you could share, that we could be here together. So this is it for today. And I hope to see you again on 27th of November. We will, of course, send the announcement in a few days for the next webinar. And for today, this is it. In Japanese, we say otsukare sama deshita. This means thank you for your good work today, literally.
Thank you.
Thank you. Thank you, Professor Vitiello.
Thank you.
Thank you all.
Tenkova, all
Thank
of
you.
you.
Thank
See you next month.
Thank you. Bye.
Bye-bye. Bye, Robert.
Hello.
Many new people.
Thank you.
Arigato,
Bye.
Tomoko-san.
また。
またね。
またね。Hi, Lasha.
Takeuchi Sensei, goodbye. Thank you for attending.
Thank
Always
you.
nice to see you.
Thank you, Livio, for coming. こんにちは。よかった。お疲れ様です。堀さん、ありがとう。